In this lesson, we're just looking at basic definitions and ideas around circles and their circumference. Defining and naming a circle. A circle is just a set of all the points that are equidistant from a common central point. You think of like a sprinkler system where a sprinkler head uh, shooting the water out and just looking at the perimeter or the outside range of that water being shot out. Circle is named by its center. So here down in this diagram, we have circle C. Just name it by the center point. You can have circles that intersect. They can either intersect at no common points where they are completely separate. They can intersect at one common point here. We'll learn that those are called tangent circles. And they could intersect at two common points like this, where you have a point here at the top and a point here at the bottom. You could also have what we call concentric circles. Concentric, concentric circles are two circles with different size but the same center. You can think of the store Target and their emblem of the Target symbol would be a bunch of concentric circles. The radius of a circle, that's the segment that extends, it has an endpoint from the center and it goes out to the edge of the circle. Every radius within a given circle or between congruent circles are equal in length. If we have more than one radius, we call them radii. And here in this diagram, we have three radii. We have AC, CB, and CD. AC is here in red, CB is here in blue, CD is here in purple. Besides radius, there are also chords within a circle. A chord in a circle is any segment that has both endpoints on the edge of the circle. So it extends from the edge of the circle to another point on the edge of the circle. So here in my diagram, we have chord EF, starts here on the edge of the circle, extends over here to F on the edge of the circle. We also have chord AB, which extends from here on the circle all the way across the circle to B. If two chords are congruent, why did that not show up right? So if we expand on the idea of chords, we would look at what makes chords congruent to each other within a circle. Um, Chords end up being congruent to each other in a circle when they are the exact same distance away from the center of the circle. Any chords that are the same distance away from the center end up being congruent to each other. Now, when we talk about a distance that a point is away from a segment, or in this case, especially a chord, um, there's actually a little bit of a difference between the two. Whenever we talk about a distance that a point is away from a segment, in general, it's going to be a perpendicular relationship where the distance forms a right angle with the segment. Now, something additional happens when we're talking about the center of the circle and a chord. The distance that the center is away from a chord is not just perpendicular, but it's a perpendicular bisector to each chord. So being that we're looking at G being a set distance away from AC, we know that it not only forms a right angle in these two positions, but AB ends up being congruent to BC. Likewise, over on the other side here, we're looking at G being a set distance away from FE. It does not just make a right angle here on either side of the E. What it does is it bisects this chord, so FE is the same length as ED. In this example, what we're looking at here is the idea that a chord is a set distance away from the center. If you remember on the last slide, what we talked about was the idea that if a chord is a certain distance away from the center, that distance is measured at a right angle. So if a chord has a radius of 10, we could draw in that 10 either here on that red dotted line or here on this red dotted line And then it says that we have a chord with a length of 4, which means FD is 4. Now the key to this is we can draw this radius really wherever we want, but we're going to draw it here because what it creates right here is a right triangle, which is key to solving this question. So we want to know how far the chord is away from the center. Well, if we have a radius of 10, we could measure this here to be 10. FD we know has a length of 4, which means this is 2 and this is 2, because this line is not just perpendicular to the chord, but it also bisects the chord. So now what we're going to do is we're going to use Pythagorean theorem in here to find out how far away G is away from FD. So we're going to set it up, a squared plus b squared equals c squared. My two legs are 2 and x. My hypotenuse is 10. And we would go through the steps of solving this using Pythagorean theorem. We get an x squared equals 96, so x is the square root of 96. We would simplify that down. 96 breaks down to a 16 times 6. The square root of 16 is 4. This is what we would refer to as our exact answer. It's our exact answer because we did not calculate it out and round it off. The key is that it is not rounded, which makes it more exact than if we did type it into a calculator to round it off. If we did calculate this out and round it off, our approximate answer would be approximately 9.8. In this problem, what we're looking at is we're looking at comparing two different chords. So what's given to us here is that EG is equal to GB, which is 10. We have that labeled in our diagram here. EG is 10, GB is 10. What that tells us is that AC and FD are both the exact same distance away from the center of the circle. Then what we also are given is that FD, this chord has a length of 4x minus 5. AC has a length of negative 5x plus 13. Now, being that those two chords are the same distance away from the center, what we know is that FD has to be congruent to AC, which in turn tells us that those two lengths are equal. Now we can substitute in our algebraic expressions here. FD gets 4x minus 5. AC gets substituted by negative 5x plus 13. We can use a little algebra here. We can add 5 to both sides, add 5x to both sides, divide by 9, telling us that x is 2. Now that we got x, we got to avoid the trap of just being satisfied with 2 as our answer and know that we got to answer a question that's asked. We need to find the length of FD. So to find the length of FD, we know FD is 4x minus 5. We're going to substitute in the 2 for the x and solve this so that our final answer for the length of FD is 3. Now, since we've been talking about chords so much, we can't leave out what the longest chord in the circle is. The longest chord in the circle has a special name to it. It's probably one that you already know. It's called the diameter. The diameter is not just the longest chord in the circle, it's also the longest segment in the circle. AB is our diameter here. There's only one diameter that I have drawn in this, even though there's an infinite number of diameters within a circle. Our diameter here would be AB. It stretches all the way across. It is made up of 2 radii. In this example, we're looking at 3 intersecting circles. We got circle A, circle B, and circle C, which have diameters of 19 inches, 20 inches, and 14 inches respectively. And our goal here on this problem is to find the length of XB. XB is right here. That's the distance between from here to here. So if we look at the diameter of A, this circle right here, this diameter is dictated to us that it is 19, which means we got a radius of 9.5. Half of 19 is 9.5. So this length here is 9.5. We have a diameter of B, which is at 20. Diameter B goes from point A to point C, because there's our circle B. Cut that in half, that gives us a radius of 10. So that means this length from A to B is 10, and the length from B to C is 10. The third piece that they gave us was that circle C had a diameter of 14 inches. So here, if we have a diameter of 14 inches, that means we have a radius for circle C at 7 inches. So here's our radius of circle C from Y to C is 7 inches. If we want to find XB, XB here would be the length of AB, the full length of that radius of circle B, minus AX. So if we take AB, which is 10, subtract the 9.5, which is AX from it, it tells us that that length XB would have to be a length of 0.5 inches or a half an inch. In this problem, we're going to use our intersecting circles to find the length of BY. BY is this length right here. They tell us that circle A has a diameter of 19 inches, circle B has a diameter of 20 inches, and circle C has a diameter of 14 inches. So to set this up, we're going to label everything we can on here. So we're going to start off by looking at the diameter of A, which is 19 inches. Half of that would give us a radius of A, which is 9.5 inches. So here's our 9.5 inches. The diameter of circle B is 20 inches. Half of that would be our radius, which is 10 inches. So we can label that twice on here, from A to B and from B to C. And then the diameter of circle C, which is 14 inches. Half of that giving us a radius of 7 inches, which would be out here at YC. So now if we want to find BY, BY looks like it's in relationship to the YC and BC segments. So we could probably ignore this side, the left side of this circle, and just concentrate on the right side. We know that BY plus YC has to equal BC. If we rework that equation a little bit, we can solve it for BY so that it equals BC, the long length, minus YC, the shorter length here. We plug in our values. BC has a length of 10, YC has a length of 7. We subtract them, and we have BY's value to be 3 inches long. That's how long that gap would be right there. Besides having special names for different segments within a circle, we also have special names for different lines that are in relationship to a circle. So the first line that has a special name for it in its relationship to a circle is called a tangent line. A tangent line is any line that intersects a circle exactly one time. This here would be an example of a tangent line, BG. You got point B here, you got point G out here. That only touches the circle at one point. That point where it touches the circle has a special name to it. I have it labeled here in the picture as point B. We call that the point of tangency, and we'll learn more about that later on in a future lesson. But that point of tangency has a special relationship when you're talking about a diameter or a radius connecting to that point of tangency and the diameter radius relationship to that tangent line. So in this BG, line BG is our tangent line to circle C. The second type of line that we have in relationship to circles is a secant line. A secant line is any line that intersects a circle twice. You can only intersect a circle with a line either one time, which makes it a tangent, or twice, which makes it a secant. It is impossible to have a line intersect a circle more than 2 times. Every secant does contain a chord, so here I have secant EF. It intersects a circle both at point E and point F. It does include a chord in there, which would be chord EF. Understand that the chord is a segment and the secant is a line. There's a very specific difference between the two. The chord does not extend outside of the circle while the secant does. Probably one of the more popular measurements that you will see in a circle besides the radius and the diameter is the circumference. Circumference is something that you should have a little bit of background knowledge on. The circumference is basically the distance around the circle or the perimeter of a circle. If we're ever talking about the perimeter of an object and you see a circle, you can automatically assume that they're talking about the circumference of that circle. There's 2 formulas for the circumference of a circle. The correct one depends on what you're working with. Are you working with the diameters or are you working with radius? The diameter formula looks like this. It's the circumference equals the diameter times pi. And if you're working with a radius, your formula is the circumference equals 2 times the pi times the radius. Now they're really the same thing because 2 times the radius is the diameter, but it's good to know both forms of that equation. When you're working with circumference, there are two different types of answers that you'll be asked to find. One of them might be the exact answer. The exact answer leaves everything in terms of pi. What that means is when you're working with the pi, you do not multiply the pi into the problem and round off your answer. Whenever you use pi, you automatically have to round it off because of the nature of pi, how it never ends and never repeats. So if we leave things in terms of pi, that allows us to carry a more exact answer, a more exact value to another problem if we have to take the answer of one problem, move it on to another one. So that's our more accurate answer, which entail is our exact answer. Our approximate answer is anytime you type in the problem onto the calculator, including the pi, and calculating that answer and rounding it off, that's when you have an approximation of the answer. Here's an example of a circumference problem that you might run across. This is a very basic problem. They're talking about finding the circumference if the radius is 7 centimeters. To find the circumference, because we're dealing with radius, we would use the formula circumference equals 2 pi r, or 2 pi times the radius. We'd plug in our value, which we know the radius is 7. Here we plugged in that 7. We would multiply the 2 times the 7 to get a 14 pi. This is our exact answer. It is okay when they're asking for the exact answer to leave things in terms of pi like this and leave them as 14 pi. The further up you get in mathematics, the more often you're going to see situations like this where you just leave it in terms of pi to move on to the next level after this question, or after this question has been done. If we want the approximate answer, we would type in 14 pi into our calculator and get our approximation answer. If we wanted to round this to the nearest hundredth, we would get 43.98. And we would drop everything else. Because we drop everything else, that's an approximation. Here's a sample diameter problem. Here we're asked to find C if the diameter is 13 inches. So we're going to use a diameter form of our circumference formula. We're going to plug in the 13 for the D, and basically you're done with the circumference. Your circumference is 13 pi. That's your exact answer. To get your approximate answer, you would type in 13 pi into your calculator, get your answer. If we're going to round this answer to the nearest hundredth, we would have 40.84 inches as our approximated answer. In this problem, what we want to do is we want to find the diameter given the circumference. So this is a little bit different, not quite as clean as the other formulas, but really not too difficult also. So we're going to use our diameter form of the circumference formula. That would be circumference equals diameter times pi. This time we would take this 136.9 meters. We're going to plug it in for the C this time. So to solve this equation for diameter, we would have to divide both sides by pi. Dividing this side by pi would cancel out your pi's. And then over on this side, you'd have 136.9 divided by pi. That's as exact of an answer as you're going to get in this problem. We would type it into our calculator to get our approximate answer here. Our approximate answer to the nearest hundredth would be 43.58. The 6 would round that up to an 8. Then you drop everything behind, making it an approximate answer. In this problem, we're asked to find the radius, given that the circumference is equal to 52 pi meters. Now, if they give you the circumference equal to something like 52 pi, this is the exact circumference. Notice they did not multiply in the pi and round it off like they did in that last problem where you had the 0.9. This is an exact measurement. Make sure when you plug in for the circumference in your circumference formula, we're using the radius version of it. We plug in the 52 pi over here, not just the 52, but the entire 52 pi. Then what we would do is we would divide not just not both sides by just the 2 or just the pi, but both 2 and pi. So over here on the right side, the pi's would cancel out, the 2's would cancel out, leaving you with just the radius. On this side, your pi's would cancel out. Then to figure out what the radius is equal to, you would just take 52 divided by 2, and then you would end up with an exact answer of 26. There is no approximate answer in here because the pi had canceled out. There's no rounding necessary, so the only answer is an exact answer.